Hello and welcome to this Functional Skills Maths Practice Paper 3 at Level 2. I'm going to start by doing Section A, which is the non-calculator section, and it's 25 minutes for 15 marks. So let's start with question 1, where Molly works at a paint shop. She needs to make 1500 millilitres of pink paint. Molly makes pink paint by mixing red and white in the ratio of 3 to 2. So red and white in the ratio of 3 to 2. How much red paint does Molly need to make 1500 millilitres of pink paint? So the 1500 millilitres isn't all red or white, it's actually the total, it's the pink. And if we've got a totals ratio, we take the total of our parts, which is 5, and we divide the 1500 by 5 to work out what our scale is. So 1500 divided by 5, because it's our non-calculator paper, will show what our working out. 5 goes into 15 3 times with 2 zeros. So our scale is 300, so we go back to our ratio, multiply each side by 300, and we get 900 millilitres of red and 600 millilitres of white to make up our 1500 millilitres. So here it's asking us how much red, so we're after this number here. It's 900, and don't forget the units of millilitres for 1 mark. Part B is asking us how much white paint we need for 1500 millilitres. We've already worked this out in Part A, so the amount of white paint, go to the W for white, is 600 millilitres, and again that's 1 mark. Question 2. What is 5/6 as a percentage? Give your answer rounded to 2 decimal places. So the first thing to do is maybe turn this into a decimal and then multiply it by 100. Because if we try and use equivalence, 6 doesn't go into 100 a nice number of times. It's not like having a 5 or a 10. So the best method to do this question is to actually turn it into a decimal and multiply the decimal by 100. So 5 divided by 6, which is exactly what this means here, is 6 doesn't go into 5, carry the 5, and don't forget to put in your decimal point to show the end of the whole numbers. 6 goes into 50 8 times, because 6 8s are 48, there's a remainder of 2. 6 goes into 20 3 times, because 6 3s are 18, remainder 2. 6 goes into 20 3 times, because there's a remainder of 2, and so on. So this turned into a decimal is 0.833, and then the 3's go on forever. Now, to turn a decimal into a percentage, we multiply it by 100. So just move the decimal point 2 places, and you get 83.33 recurring as our percentage. We need it to 2 decimal places, so here, so it's 83.33%, and that's worth 1 mark. Question 3. Calculate 13% of 300 grams. So whenever you get a percentage question in the non-calculator paper, always remember your 10% rule. So to get 10% of the value, divide it by 10, so 10% is 30 grams. Now, we also have a 1% rule, where if we divide it by 10 again, we end up with our 1% value, which is 3. We don't want 1%, we want 3 lots of that to get our 3%, which is 9. So add your 10% and your 3% together to give you the 13% value, which is 39. Question 4. It wants us to work out 1 3/4 plus 2 1/2. Now, because we've got quarters and halves, we should be thinking about doing this as our clock times. So if we start off at 1 3/4, in other words 1:45, and we add 2 hours, we end up at 3:45. Now, if we add half an hour to 3:45, if you're thinking of your clock face, you end up at 4:15 or 4 1/4 with respect to our fractions. So the correct answer is C, so tick box C, which is 4 1/4 for 1 mark. Question 5. Work out 1/3 plus 3/8. Now, you can't just add them together because the denominators are different. So we need to make the denominators the same and find a number that 3 and 8 have in common. And the quickest way to do this is just multiply them together. So 3 times 8 is 24. So they have 24 in common. So all we need to do is ask ourselves, how did I get from 3 to 24? Well, I multiplied the 3 by 8 to get the 24. I do the same for the numerator. So 8 over 24 is the same as 1/3. Our value of our fraction hasn't changed. We've just changed the way it looks. Now on the other side, how did I get from 8 to 24? I multiplied it by the 3. So in this case, we need to multiply our numerator 3 by 3 to get 9 over 24. So the fraction 9 over 24 is the same as 3 over 8 value-wise, it's just written in a different way. But because they now have a common denominator of 24, I can add the 8 and the 9 to get 17 over 24 as my answer. Now we've created an answer, can we simplify it? Well, we should recognize that 17 is a prime number and 17 doesn't go into 24. So our answer for 1 mark is 17 over 24. Question 6. Amaya wants to buy a new mobile phone and she sees this offer for a mobile phone. The monthly cost is £59 and the mobile phone cost is £39.96. Estimate how much it would cost over 2 years. So the buzzword here, estimate, means we can round these numbers to make the maths easy for ourselves. So £59 is close to 60 and £39.96 is close to 40. Now we want it for 2 years, so let's call it 20 months because a year is 24 months. And if we round that and make it easy, let's call it 20. So 20 months at £60 a month is 6 times 2 is 12 with 2 zeros is £1,200. And then we need to add the £40 for the price of the phone. So our estimate is £1,240. The next part shows that she sees another offer at the same phone, but this time it's a SIM-only offer where the monthly cost is £11 and the mobile phone is £889.92. So Amanda says that I will save over £300 over the 2 years if I choose this offer. So we need to use estimation again. So our £11 becomes 10 and our £889.92 becomes £900. Now, we've got it over 2 years again, so we're going to use 20 months again because we're using our rounding, times the £10 a month is £200 over the 2 years. We need to add the £900 for the price of the phone, and we end up with £1,100. She says she's going to save over £300. So if we take our 1,240, which is our original estimate here, take away our 1,100, we end up with £140 as our difference. So she's not going to save as much as £300. So use estimation to check her statement. She is incorrect. She's going to save more like £150 rather than the 300 she's looking at. So our evidence for this mark is here. Question 7. Michael buys a new fish tank and the diagram shows the water in the tank. Work out the volume of water in this fish tank. So to work out volume, you need to multiply the 3 dimensions. So 30 times 100 times 30. Well, 3 times 1 is 3, times 3 is 9, and there's 1, 2, 3, 4 zeros. So the volume of the fish tank is 90,000 centimeters cubed. Now, Michael knows that 1 litre is 1,000 centimetres cubed. Work out how many litres of water the fish tank can hold. So this is a strap line between litres and centimetres cubed that we can use. So we have 90,000 and we need to know what we multiply 1,000 by to get 90,000. We multiply it by 90. Multiply the other side by 90 and it tells us that we have 90 litres in the tank. Then part C. Michael can keep 2 small fish for every 5 litres of water. He thinks he can keep more than 20 small fish in his tank. Is he correct? So here we have a relationship between the fish and the number of litres. And we know from above that the tank has 90 litres. So how did I get from 5 to 90? What is my scale? Well, divide the 90 by 5. And it tells you your scale is 18. So multiply the other side of your ratio by 18. And it tells you he can keep 36 fish in his tank. So is he correct? Well, he says 20. We've calculated 36. Yes, he is correct. And the evidence for this is you're working out here. Question 8 is bid mass. So we need to write down bid mass and look at things in order. So are there any brackets? Yes, there are. So we do what's in the bracket first. The bracket has 2 calculations. So we then go down bid mass and we do the division and multiplication first. So inside the bracket, we have 9 plus 6, which gives us 15. Now we can open the bracket and square 15. So we need to know what 15 squared means, which is 15 times 15. If you can't do it off the top of your head, just use your box method to make the calculation easier for yourself. So 10 times 10 is 100, 10 times 5 is 50, 5 times 10 is 50, and 5 times 5 is 25. Add them across, so I've got 150 there, 75 there, and we end up with a total of 225. So the answer to our bid mass question is 225 for 1 mark. Question 9 wants us to work out the subtraction of 2 quite long decimals. So use the column method where you have 258.362 and you're going to subtract 153.409. 9 from 2 doesn't go, you need to borrow 1. 9 from 12 is 3. 0 from 5 is 5. 4 from 3 doesn't go, so we need to borrow 1. And 4 from 13 is 9. Put in your decimal point. 3 from 7 is 4. 5 from 5 is 0. And 1 from 2 is 1. So the answer is 104.953 for 1 mark. Question 10. The distance between 2 cities is 7 centimetres on the map. The map has a scale of 1 in 50,000. What is the actual distance in kilometres between these cities? So our strap line is our 1 in 50,000. And you need to remember when you have a scale like this that it's centimetres to centimetres. Our map is on the left-hand side, so our reading from our map goes on the left, and we've multiplied it by 7. So we need to multiply the real world by 7. So 7 5s are 35 with 1, 2, 3, 4 zeros. So we have 350,000 centimetres. It wants the answer in kilometres, so we do it in 2 stages. We go from centimetres to metres by dividing by 100. Centi means 100, small to big we divide. So if we divide this by 100, we have 3,500 metres. To go from metres to kilometres, kilo means 1,000, so we divide by 1,000, 10, 100, 1,000. We end up with 3.5 kilometres as our answer for 1 mark. Question 11. Here's a table that shows the number of hours each employee works at a company. Calculate the median hours. So you need to remember the median is the middle after we've sorted it. So we're going to take this data and we're going to put it in order. So our lowest number is 14.5. Our next lowest number is 15 and then 18.5. The next lowest after this is 25.4. Our next after this is 32 and then 32 again. And then finally we have 36. Now we have 1, 2, 3, 4, 5, 6, 7 bits of information. So we're expecting one number in the middle. So cross them out from each end and you're left with the median, which is the middle number, which is 25.4 hours is the median. And that's worth 1 mark. And that's the end of section A, where you had 15 marks available and 25 minutes in which to answer those questions. Now let's look at section B. This is a calculator allowed section where you have 1 hour and 20 minutes to do this section and there are 45 marks available. If you can use your calculator on anything other than basic addition, subtraction, multiplication and division, I will show you anything more complicated on our virtual calculator. Okay, let's start with question 1. What is the mode of these numbers? So the trick is the mode means the most, so you don't have to sort them or organize them or add them or anything. Just look through the numbers and try and work out which number appears the most just by looking at them. So I can see 95 appears 3 times, so for 1 mark I put 95 on the answer line. Question 2. Write these numbers in increasing order. So the smallest first, so they're all different lengths. This has got 4 digits, 3, 2 and so on. So make them all the same length and now you can compare like with like. So the smallest number I've got is 95. So put this one down first. Then the next smallest number I've got is 1200 as opposed to 1205. So 0.12 would be next, followed by 0.1205, and then finally 0.502 as our biggest number. And that's worth 1 mark. Question 3. Greg is travelling to New York. He wants to change £500 into dollars. How many dollars does he get for his pounds if the exchange rate is £1 to $1.24? So we're doing a ratios question and it's a parts ratio and they've given us our strap line where £1 is $1.24. We've got £500 to change, so the pounds live under the pound side of our ratio. So how did I get from 1 to 500? My scale is 500. So I have to do the same on the other side. So on your calculator, multiply 1.24 by 500. And you should get 620. So on the answer line, don't forget it's dollars and it's $620. Question 4. Darren throws 2 fair dice. The numbers on dice A are 1, -2, 3, -4, 5 and -6, and the numbers are on dice B are -1, 2, -3, 4, -5 and 6. The table shows some of the total scores for throwing the dice, so they've filled in some of them for you. So for example, 2 plus 1 is 3, -1 plus 1 is 0. And for 1 mark, they need us to complete the table. So 2 minus 2 is 0, 3 minus 3 is 0, 4 minus 4 is 0, 4 plus 3 is 7, 4 plus 5 is 9, 4 take away 6 is -2. -1 plus 5 is 4. 2 take away 6 is minus 4. Minus 3 plus 5 is 2. Minus 3 minus 6 is minus 9. Minus 5 minus 2 is minus 7. Minus 5 minus 4 is minus 9. 6 plus 1 is 7. 6 take away 2 is 4. And 6 plus 5 is 11. So your table should look like this for your 1 mark. Now, using the table above, what is the probability that the total score is minus 11? Well, there's only one minus 11 on our matrix of scores. So there's one outcome out of, and there are 6 by 6 combinations. So there are 36 combinations. So the probability of scoring minus 11 is 1 over 36 for 1 mark. You don't have to turn it into a decimal or a percentage or anything. You can leave it as a fraction and you will get the mark. Darren throws the 2 dice again. What is the probability that the new total score is 0? So going back to our table, we need to see how many outcomes give us 0. So there are 1, 2, 3, 4, 5, 6 outcomes that give us 0. So the probability of scoring 0 is 6 out of 36. Now don't forget, whenever you create a fraction, make sure you try and simplify. So 6 divides into 6 once, 6 divides into 36 6 times. So the probability is 1/6. And that's worth 1 mark. Question 5. Mark had 2 jobs. Mark worked in an office for 12 months and earned £2,600 per month. He also worked at a gym for 39 weekends and he earned £80 per weekend. What fraction of his total income for last year came from the work at the gym, and what fraction is it in its simplest form? So the first thing we need to do is we need the total income for last year. So we need to work out what he earns in a year. So he has 12 months at £2,600 a month. Do this on your calculator and you can see he earns £31,200 from the office job. Do the same for the gym work, so it's 39 weekends at £80 for each weekend, and that is 3,120. So the total for the year is 31,200 plus the 3,120. And you have £34,320. So now we need to create a fraction of his total income, which is 34,320 for last year, that comes from his work at the gym. So his gym work is the numerator, 3,120. All you need to do to simplify this is put it in your calculator. Let me show you. Use the fraction button, put 3,120 on the numerator and 34,320 as the denominator, and just press equals, and look, it simplifies it for you as 1 over 11. So 1 over 11 is the simplified fraction for how much he earns at the gym. And that's worth 4 marks. So notice how I do all my working out, no matter how simple it is. I have an audit trail for where every number comes from. Question 6. Here is a cube of side length 2.5 centimeters. Work out the surface area of this cube. So if we work out the area of the face that's facing us and multiply it by 6, because there are 6 faces, that will give us our surface area. So the area of the face that's facing us is 2.5 centimeters times 2.5 centimeters, which is 6.25 centimeters squared. And there are 6 faces, each with this area, because it's a cube, they're all the same. So 6.25 times 6 equals 37.5, and the units are centimeters squared because it's the surface area of this cube. So 37.5 centimeters squared, and that's worth 3 marks. Question 7. Here is a prism. The cross-section of the prism is a pentagon. Draw the front elevation of the prism on the grid using the scale 1 to 3. So we need to draw this shape onto our diagram using a scale of 1 to 3, where we have our drawing and our real prism. So for example, the base here is 18 centimeters, so the scale is 6, so I need 6 centimeters to represent this. So 6 squares will represent that. Same for the 15. If we divide it by 3, we end up with 5 squares for this. We've got 4.5 for this edge here. So if we use it here, 4.5. So to get from 3 to 4.5, we've multiplied it by 1.5. So we need 1.5 squares for that measure. And then whatever's left, so we don't have to have the measure, we will just join this end to this end on our drawing, and it doesn't matter, the drawing will give us that length anyway. We don't have to worry about that particular length. So let's just draw what we have. And let's start with the base of 6 squares. So this base of 6 squares in the real world represents our 18 centimeters. Then we're going to draw the left-hand side where we want 5 squares to represent 15 centimeters. So let's draw that. So this left-hand side is 15 centimeters in the real world, but 5 squares on our drawing. Next, let's draw the top, which is 10.5 centimeters. So 10.5 centimeters. So to get from 3 to 10.5 is 3.5 squares. So we need 3.5 squares to go from the top of the 5 across. So let's go back to the drawing and draw that. So these 3.5 squares represent 10.5 centimeters. Next, we'll draw this right-hand edge, which we know is our 4.5 centimeters, so 1.5 squares up. So we're just going to draw a line 1.5 squares up from this bottom right-hand corner. So this right-hand side is 4.5 centimeters. Now when we go back to our drawing, so we've drawn this left-hand edge, the base, the top, and this right-hand edge. Now there's no measurement here, so we don't have to measure it. All we need to do is connect this end here to this end here, and then that's our drawing complete. So let's do that. And that's our drawing complete. So we've got our 18 centimeters, our 15, our 10.5, our 4.5, and then these two ends we just join with a straight line, and we now have our scale drawing of our original prism here. Question 8. Olga has this sketch of the paths in a park. She wants to cycle a route that starts and ends at the entrance, so it starts and ends here, goes through point C at least once, and has a total length between 15 and 20 kilometers. They've given us a conversion because we have miles on our drawing, so our strap line is kilometers to miles. 1 kilometer is 0.6 of a mile, and we need to plan a suitable route and then work out the total distance of the route. So first of all, let's work out how many miles we can play with before we start designing our course. So if we've got our conversion and we want to convert the 15 kilometers, on this side 1 is multiplied by 15 to give us our 15. So multiply by 15 on this side and we have 9 miles. So that's the minimum distance that our route can be. Let's do the other conversion then. So we have 20 kilometers to convert. So we've multiplied that side by 20. So on this side, we multiply by 20 and it's 12 miles. So our route needs to be between 9 and 12 miles. So let's start planning the route by adding some things together. So let's do a bit of practice. You might want to do this rough. So start from the entrance and go to point D. So that's 1 3/4. Then we'll go to point C, which is another 2 1/4 miles. And then let's go to point B, which is 4 1/2 miles. Let's add that up and use your calculator to do this. So we have mixed numbers, so shift and the fraction button. 1, rocker to the right, 3, rocker down, quarters, rocker to the right, plus shift, mixed numbers, 2 and rocker to the right, 1, rocker down, 1/4, and then rocker to the right, add our final amount, shift, fraction button, 4, rocker to the right, and 1/2. Press equals, press SD, and we've got 8 1/2 miles at this point. So if we go straight back from B through F to the finish, then that will take us above our 9 miles minimum. So let's do that then. Let's then add from B to A, then F, and then back to the entrance. So we've got to add 1/2, 1/4, and then another 1/4. So on our calculators, we should still have our 8 1/2. So just use your answer and then add the half, which we'll call 0.5, add another 1/4, which is 0.25, and a final 1/4, another 0.25. So our total is 9 1/2 miles. So this route would be acceptable because it's above the 15 kilometers, that is 9 miles. So work out the total distance for the route and plan the route. So our plan for the route is here. We're going to go from the entrance to D, to C, to B, to A, to F, and then back to the entrance. And our distance is 9 1/2 miles. So on the answer line, we can put our 9 1/2 miles as our distance, and then our justification and working out is that scribbling that I did at the top. And that question is worth 5 marks. Question 9. Mona is the manager of a computer shop and she organises a sale with 18% off all of the tablets. Mona changes the price on the tablet from £3.89 to £330.98. Has Mona changed the price correctly? So there's several ways of doing this. What we can do is take the 18% of the 389 and then take it away to see if she's got the correct price. So on your calculator, exactly as it looks as I've written it, 18 shift bracket button to get the percent of, and then 389 equals. So she should have taken off for 80% £70 and 2 pence. So let's check that. £389, take away £70 and 2 pence is £318 and 98 pence. So has Mona changed the price correctly? No, it is incorrect. And the working out that justifies this answer is here. She's actually reduced it to £330.98 when it should have been £318.98. It says use approximations to check your answer. So if we check the calculation that we've done here, then our approximation could be 20% of, let's call it £400. So we know 10% would be 40. So 2 lots of 10% would be £80. We've got £400. We take off the 80. Approximately, we would expect the figure to be around £320, which it is up there. So that's checking our answer using approximations.
Question 10. A team of workers deliver identical fridges. The team will use the average time to fully load an old lorry to predict the time to fully load a new lorry. The table shows the times it took to fully load the old lorry with 24 fridges, and we've got the times here. The diagram shows the space available for fridges in the new lorry. The space is in the shape of a cuboid. Each fridge needs a rectangular floor space of 1000 millimeters by 800 millimeters. The team do not stack fridges. They think it will take less than 90 minutes to fully load the new lorry. Are they correct? Well, let's start by working out the average time it took to do the 24 fridges, because that's going to come in useful later. So the first thing we do is we work out the sum of these numbers. So the total sum of the minutes on my calculator comes to 399. And when we divide it by 1, 2, 3, 4, 5, 6, 7, because there are 7 samples, it gives us a mean time of 57 minutes. So that's our strap line for working out the times. Fridges to minutes, 24 fridges in a mean time of 57 minutes. And we'll come back to that in a minute. Now, we need to find out how many fridges fit into our lorry. And we have 2 dimensions. We have 1000 millimeters by 800 millimeters. So if we laid the fridges down, we're looking at how many fridges fit across this way. So if we have 2400 divided by 800, again on our calculator, we fit 3 fridges across. So now we need to know how many fridges we can fit along the lorry this way. So that's 13,600 divided by the second dimension, which is 1000 millimeters. And that's 13.6 fridges. Now, you can't get 0.6 of a fridge, so rounded, this gives us 13 fridges in that dimension. So the total number of fridges is 3 across and then 13 along the back of the lorry. So 13 times 3 on your calculator is 39 fridges is the capacity of the new lorry. Now, this is where our strapline comes in from earlier. We don't have 24 fridges, we have 39 fridges this time. So to find our scale, in other words, what have we multiplied 24 by to get our 39? 39 divided by 24 gives us our scale, which is 1.625. So multiply by 1.625 on one side, do the same on the other. So 57 times 1.625 is 92.625 minutes. So now we have enough information to answer our question. We don't have to worry about converting our decimal minutes. We can see clearly that the 92 is greater than the 90 minutes they suggested. So are they correct? No, as it will take an estimated 92 minutes to load the lorry. And all of those calculations are worth 6 marks.
Question 11. Lorna makes a cake. The cake is in the shape of a cylinder with a diameter of 14 inches. Lorna needs to put a ribbon around the cake, and the ribbon will go around the cake once, and then there'll be a 6-inch overlap. Lorna has a piece of ribbon 48 inches in length. Is the piece of ribbon long enough for this cake? So to work out how much ribbon goes around the cake, we need the circumference of our cake, which is equal to pi times the diameter. And you need to remember that for the exam. You're not going to be given it. So the circumference is 3.14 times the diameter, which is 14. Put this in your calculator and you get 43.96 inches. We need to add the 6 inches for our overlap, and we end up with 49.96 inches that we require. Her ribbon is 48 inches long, so to answer our question, no, she does not have enough. And then the working out to justify this is the working out that we have above. Question 12. Bert will cover part of a floor with tiles. The part of the floor is in the shape of a triangle as shown. Bert buys tiles in packs. Each pack covers 1 metre squared and costs £39.95. The tiles can be cut and joined, and Bert gets 1/3 off the cost of the packs of tiles. Work out the lowest cost of the tiles for Bert. So before we start, we need to see that we need to be working in meters squared to work out the area, so we can then work out the cost. And we've been given centimeters for the dimensions of our triangular shape. So the first thing we need to do is convert these from centimeters into meters. So for 305 centimeters, to convert it into meters, we need to divide by 100. A small unit to a large unit, we divide centi by 100. So divide by 10, divide by 100 is 3.05 of a meter. Then for this dimension here, again, we take the 371.5 and divide it by 100. So we end up with 3.715 meters. So now our dimensions are in meters, and when we multiply them, we'll get meters squared for our units of our dimensions. So let's do that. Let's calculate the area of a triangle. So you should remember it's half the base times the height. So it's a half of 3.05 times 3.715. So let's put that in our calculator and see what we get. And we get 5.665375 meters squared as the area of our triangle. Now, because we are talking about the packs covering whole meters, we can round it to the nearest whole number, but we need to round up because we can't buy 5.6 packs. It looks like we're going to need 6 packs of tiles so that we cover our area of 5.66 meters squared. So we've got 6 packs at £39.95. So let's work that out. And that's £239.70. And we're going to get 1/3 off. So we'll calculate 1/3 of that amount, which is 79.9, and that's our discount. So don't forget, you need to take it off your original amount. And that gives us the lowest cost we can get the tiles for Bert. So it's £159.80. Notice put in the second decimal place when you start putting in the money symbol. So on the answer line, the price of £159.80, and that's worth 5 marks for the working out. So the calculation of the area and the number of packs and so on. Question 13. The scatter diagram shows the information about 12 athletes who have run a race. So on one axis, we've got their time in minutes, and on the other, we've got their age in years. So for part A, we need to plot this information here. So another athlete who's 36 years old runs 29 minutes, and we need to put that on the diagram. So we've got an age of 39, so he's 39 years old, and he does it in 26 minutes. So we put a little cross there for our 1 mark. Then it asks us to draw a line of best fit on the scatter diagram. So draw the line as close to all of the crosses as you can. It doesn't have to go through any particular cross, and it doesn't have to go through 0. And make sure the line extends to the extremities of the display. So this is my trend line, and it could be slightly different for yours, but as long as it kind of looks in this general direction, then that's fine. So drawing the trend line is the line of best fit is 1 mark. Describe the relationship shown in this scatter diagram. So the relationship going in this direction from bottom left to top right is what we call positive correlation, which means the older the years, the longer the run takes. So as a minimum for the mark, describe the relationship. It shows positive correlation, and this is the buzzword they're looking for that relationship, and it means the older somebody is, the longer they take. And again, that is worth 1 mark. Question 14. Gina wants to buy a flat, and the flat costs £175,000. The bank uses this formula to work out the mortgage Gina can get, where the mortgage is equal to 4.625 times the amount for annual income. So Gina has an annual income of £34,000. She will have to pay a deposit for the flat. The deposit is the difference between the cost of the flat and the mortgage. Work out the deposit Gina will have to pay. So let's work out her mortgage first. So her mortgage is equal to 4.625 times her wage or annual wage of £34,000. Do this on your calculator. 4.625 times 34,000 equals £157,250 is her mortgage. So the deposit is the cost of the flat, which is £175,000. Take away her mortgage, which is £157,250, and it leaves you with her deposit, which is £17,750. So on the answer line, for 3 marks, 17,750 gets you the 3 marks. And that's the end of section B, where 45 marks were available, and you had 1 hour and 20 minutes in which to complete it. If you have any questions on this video, please don't hesitate to ask your tutor. I hope this video has been of some use.